Hello, this is Alex Eames from RasPiO.tv. So today I'm going to show you how to put together your RasPiO Analog Zero board and turn it from this bag of components to an assembled board ready to play with. So the first thing I'm going to do is lay out the components in the same order they are on the label. So you've got two capacitors, they're going to go here. You've got an 8-way header, that's going to go here. You've got a chip socket, that's going to go here, but the dimple is going to be at the top. You've got a 2-way male header, that's going to go here. A jumper, that's going to fit on the male header. You've got a chip, the dimple will go at this end, and you have a 40-way GPIO header, which is going to go here, but on the other side of the board. And if you've got all of the parts, let's start putting them together. Generally, when you're soldering a board, you start with the lowest components and work upwards to higher components. So my suggested order is you start with the chip socket and do that first, then the two capacitors, then the 2-way male header, then the 8-way female header, then the 40-way GPIO header, then the chip, and I'll show you how to put the chip in, and then right at the end you fit the jumper. So let's get started. A technique that I use quite a lot is using a sponge to hold the component to the board. So let's start and I'll show you how. So we've got the PCB and we've got the chip socket, which is the first thing I suggest you start with. So let's take that out of the protective foam, and you'll notice it has a dimple at one end. There, just there's the dimple, okay? And you'll also notice on the PCB there's a dimple there. That needs to be at that side, ideally. It doesn't actually make any difference, but that's how it's supposed to be. So, using the sponge, we can put that on top of the PCB and flip it over, and what it then does is it holds the component up against the board while we solder. I'm going to use my soldering station and leaded solder. I prefer using leaded solder because it melts and flows most easily. Unleaded solder is a bit harder to use. Okay, so let's solder the chip socket. I normally use an extraction fan, but the noise of it will make it difficult for you to follow the video if I speak or something, so I'm not using that today. That's why I'm blowing the flux vapor away, so I don't have to breathe it in, because it gives me a sore throat. Okay, so that's the chip socket soldered. What's next? Capacitors. We've got two of these capacitors. They are both 1 microfarad. It doesn't matter which way around you put them in. So what I generally do is splay the legs out slightly, and I try to make sure the text on each of them is facing the same way. It doesn't matter which, it just looks nicer for the photos. You won't necessarily need to worry or care about that. Okay. Alright, so those two capacitors are placed. Let's do the sponge trick again to hold them in place. Okay, now we take the solder the soldering iron and we hold the board down. Put the iron on the component and try to touch the pad at the same time on the PCB. That way you can usually get a nice joint. Now let's flip the board over and get those aligned before we do the second half of the joint. Okay. Okay, so then we will need to get our snips. You can use ordinary side cutter snips like that, or if you have them you can use something like this, which gives you really nice close cut, close to the, and you should technically hold one end so that the part doesn't ping and get you in the eye. But even if it did, you're wearing eye protection, right? Because everyone always wears eye protection when they're soldering. Well, they're supposed to, theoretically, but I don't actually know anybody who does. Right. Everyone says you should, though, to avoid getting sued. So, always wear eye protection when soldering. Next up, we have the two-way male header. This header is used on the board to connect the voltage reference pin to the 3v3 of the Pi. As explained in the manual, you can do things differently. If you want to connect your voltage reference to something else, you can do that, but you still need the header on unless you're going to hard solder it to something else. So we'll solder on that pin. And that seems nice and straight. If it's not straight, the best way to make sure it's straight is to actually solder one pin and then check that it's straight. If it's not, you can adjust it. But actually I did that right first time, so no need for any of that nonsense. Fantastic. So the next thing we want to solder on is the 8-way header, if you're going to use it. In most cases I do, but if you were going to do something that you wanted a nice flat installation for, you might find that it's too high if you wanted to hardwire your wires straight into the analog inputs. So let's solder that one now. Let's move it to the middle so you can see a little bit better. This time I am going to make sure that it's properly aligned before I commit. So let's check. How does that look? It's vertical, but it's a little bit wonky that way, so I know I'm tremendously fussy. But we are on camera after all, so it's got to look good. Okay, let's just do that one. Blow that nasty fumes out the way. Okay, that looks pretty straight. Is it vertical? Yes it is. Right, let's do the rest. One, two, three, four, 5, 6. And they're all nicely done, so we now have a space to poke our wires for the analog inputs. Next up, I think we have the 40-way GPIO header, which is this beastie here. Now, if you're going to put it down on your Pi, it has to be this way around, right? So that has to go to the underneath of the board. Now normally I actually discard the sponge at this point. Make sure that the header is nicely lined up, and then just go ahead without. I'm going to take a fresh piece of solder wire and do one pin, then check the alignment. That looks nice and flat to me. Okay, let's carry on then. Do another pin. Okay, and one more final check. Right, that looks good to me, so let's do the rest. This isn't quite how I normally solder. I'm doing it a little bit differently so that hopefully my hands aren't blocking your view. Some of the pins may be a little bit more stubborn than others. Generally those are the earth pins, ground pins, because you're heating up not just the pin and the pad, but the ground plane of the board as well. So you're heating up a lot more copper on the ground pins. Notice the reason for using a chip socket is so that we're not likely to damage the chip from soldering. If you are quick and you know what you're doing, you can get away with soldering a chip directly to the board, but then if you damage the chip or want to change it, for example if you wanted to upgrade to a 12-bit chip, you wouldn't be able to if you'd soldered it straight to the board. But if you've got it in a socket, you can change the chip, so that's quite handy. That also prevents overheating and damage during assembly. So this is probably the longest operation of the whole procedure. Look at that. Nasty solder vapor. That isn't lead, that's flux vapor. It isn't poisonous, it's just resin. I think it's usually resin from a pine tree or something like that. But it does irritate, and it can, particularly if you're sensitized, it can irritate your throat and give you a nasty cough, which is one of the reasons why in commercial environments you have to have an extraction system. Okay, so that's the GPIO header soldered. A quick check of all the ports, and looks okay to me. Right, next step, put the jumper on. So we connect VREF to 3V3, press the jumper on, it's now connected. If you ever want to use a different VREF, you take the jumper off and connect your voltage source to that pin there. Okay, one thing left to do, that's to fit the chip. Now you'll notice there is a circle and a dimple. Those need to be at this end. Okay, the chip doesn't quite fit when you take it out of the foam. This is conducting foam that helps to prevent electrostatic damage to the chip. What we need to do is, you can see those pins are kind of angled out. We need to roll the chip slightly on a flat surface, just a little bit, to slightly bend the pins. Can you see they're almost straight now? Slightly bend the pins on each side so that they will fit nicely in the chip socket. So we make sure we've got it the right way around, dimple that way, dimple facing that way, dimple there on the board. The dimple needs to be next to the caps. And then we place the chip in the socket. You can see, having bent the pins, it fits nicely, and then you just press and you should be able to hear a kind of crunch. And when it's pushed firmly in, there should still be a little gap there, but there you can see your board is now complete. Now, as one of the stretch goals, we actually chucked in 3 extra headers. If you choose now to fit them, you could put them anywhere. You could put them on the 5-volt rail, ground and 3v3, or if you want to attach a display, you could put them there to make use of the I2C ports. But my recommendation is, unless you know exactly what you're going to use them for, you don't need to fit them just yet. Wait and see what experiments you want to do. It may well be that you decide to fit more than 3 and get some of your own and put some. Some people have decided to put one all the way along there. Some people might even decide to populate the entire prototyping area and make themselves a sort of onboard mini breadboard. That's all possible. But provided as standard, you have these 3 headers, and if you can't decide where to put them, ground and 3v3 is probably a good place. Then if you're going to attach one of the character LCDs, you might want to put one here for the I2C ports. That's my most common configuration, but as you can see on this one, I've done that and added a further one to the 5-volt, which is quite useful. So that didn't take long, did it? And it wasn't very difficult. I do apologise for the rather dirty looking background, but this is a box that I often do my soldering on, and it's at exactly the right height for me to work comfortably without getting a neck or back strain. So that's the reason I used it. I might have to see if I can find something a little bit cleaner for future work, but you can see scorch marks here from where I've done hot air gun soldering and it's scorched the wood. Hopefully now you know how to put together your RasPiO Analog Zero board, and you can see that it's not very difficult and it doesn't take very long.
This was Alex Eames for RasPiO.tv. Thank you for watching. Please remember to like, share and subscribe.